September 8, 1944. 6:43 p.m., Chiswick, London. A woman named Mrs. Ada Shea. Harrison was standing in her kitchen preparing dinner for her family. The sky was quiet. No air raid sirens. No warning at all. Then, without sound, without notice, her entire world exploded. A massive blast tore through Staveley Road, flattening homes, shattering windows blocks away. 3 people gone in an instant, 17 others injured. And only after the destruction came the sound, a roaring, thunderous scream tearing through the sky. Something had just struck London. But it hadn't come from a plane. It hadn't been dropped by a bomber. It had arrived from space, traveling faster than sound itself, faster than any aircraft, faster than anything humanity had ever built. This was the V-2, the world's first long-range ballistic missile, and it had just rewritten the rules of warfare. Here's the question I can't stop thinking about. If you heard an explosion before you heard the weapon coming, how do you defend against something you can't see, can't hear, and can't stop? Drop your thoughts below, because that's exactly the nightmare London faced for 7 months. And this is the story of the machine that made it possible. The revolution. No one could stop. The V-2 wasn't just a weapon. It was a statement, a glimpse into a terrifying future. Standing 46 feet tall, powered by liquid fuel, guided by gyroscopes, this single-stage rocket could carry a 1-ton warhead over 200 miles. It reached speeds exceeding 3,500 miles per hour, nearly 5 times the speed of sound. It climbed to the edge of space, 128 miles above Earth, becoming the first human-made object to leave the atmosphere. And then it fell. Silent, unstoppable, devastating. No air raid siren could warn you. No fighter plane could intercept it. No anti-aircraft gun could shoot it down. By the time you heard it, it had already hit. Anatomy of a monster. Let's break this machine down, because understanding how it worked makes what it achieved even more unbelievable. The V-2 was composed of 4 main sections. The warhead. At the tip sat 2,000 pounds of amytol, a mixture of TNT and ammonium nitrate. Cheaper than pure TNT, but devastatingly effective. 3 fuses ensured detonation, a contact fuse beneath the nose, 2 inertial fuses inside. Any one of them could trigger the blast. The guidance section. Just below the warhead was the brain of the operation. Inside this compartment, 2 gyroscopes, one for pitch, one for yaw and roll. An analog computer that processed data and adjusted flight path. Batteries powering the entire system. Compressed air bottles maintaining fuel tank pressure. It wasn't perfect, but for 1944 it was revolutionary. The fuel section. The largest part of the rocket housed 2 massive tanks. The upper tank held 8,179 pounds of beestoff, a mixture of 75% ethanol and 25% water. Below it, 10,802 pounds of liquid oxygen, kept supercooled and constantly evaporating, requiring continuous topping off right until launch. Both tanks were insulated with glass wool, pressed tight with wooden blocks to survive the violent acceleration. The engine section. At the base, the heart of the beast. A liquid propellant rocket engine capable of producing 55,000 pounds of thrust. At maximum power, 64,000 pounds. 4 stabilizing fins extended from the tail, each fitted with external air vanes and internal graphite jet rudders to steer the missile through the sky. It was elegant, brutal, ingenious, and it worked. The engine that changed everything. To hurl a 1-ton warhead 200 miles required something extraordinary. German engineers designed a combustion chamber with a double-walled structure, fuel lines running between the walls, cooling the chamber while heating the fuel. Genius. At the top of the chamber sat the injector head. 18 burner cups arranged in concentric circles, feeding fuel and oxygen into a precisely controlled inferno. Inside, temperatures reached 4,532 deg. Pressure hit 15 bars. The mixture ignited, burned, screamed. To supply fuel at the necessary pressure, a turbopump driven by steam spun at 5,000 RPM, forcing fuel and liquid oxygen into the chamber every second. 158 pounds of oxygen, 127 pounds of fuel. Every single second for 70 seconds. That's all the fuel it had. But 70 seconds was enough. Getting it to the launch site. The V-2 couldn't just be rolled out and fired. It required an entire mobile operation. Stored in protected bunkers, empty, without warheads, the rockets were transported using a specially designed trailer called the Meillerwagen, towed by a 100-horsepower wheeled tractor. At the launch site, the Meillerwagen elevated the rocket and carefully positioned it onto the Abschuss platform, the firing table. This portable steel platform weighed 3,160 pounds and featured 4 adjustable legs to level it on uneven ground. At its center, a blast deflector shaped like a pyramid, tipped with hardened steel. It could withstand the rocket's exhaust and disperse gases laterally, preventing instability during liftoff. Preparing for launch. Once positioned, the rocket was rotated 90 degrees, aligned with the target using maps and precise triangulation. Then came fueling. First, a dry purge with compressed nitrogen to check for leaks. Then the tanks were filled. Fuel first, then liquid oxygen, then smaller tanks for the steam generator. External electrical power was connected. The rocket was checked again. Perfectly vertical, properly aimed. Hatches closed. Lifting frame lowered. Meillerwagen moved away. An electrical igniter was connected to the combustion chamber. The launch crew cleared the area. Inside the command vehicle, the troop commander gave the order. Launch. Ignition. Inside the rocket, pressurized nitrogen forced hydrogen peroxide and sodium permanganate into the steam generator. The mixture reacted. High-pressure steam exploded. Through the turbopump, spinning it at 3,800 RPM, fuel and oxygen flooded the combustion chamber. Ignition. A controlled burn, just enough to verify the engine was functioning. If all was well, the turbopump accelerated to 5,000 RPM. Thrust surged to 55,000 pounds. Electrical cables disconnected electromagnetically, and the rocket, slowly, then faster, lifted from the ground. Flapper flight. For the first 5 seconds, the V-2 climbed vertically. Then, a mechanical motor tilted the gyroscope controlling pitch, signaling the rocket to angle its nose downward, gradually, precisely. At 25 seconds, it broke the sound barrier. At 54 seconds, it was pitched 49 degrees from vertical, traveling so fast that air rudders alone could guide it. The gyroscopes monitored every deviation. Pitch, yaw, roll. Any deviation triggered a signal to the analog computer, the Mischgerät, or mixing device. The computer calculated corrections and sent commands to the air vanes and jet rudders, keeping the rocket on course. At a predetermined velocity, calculated before launch, a device called the PIGY-A, Pendulous Integrating Gyroscopic Accelerometer, signaled engine cutoff. The engine died. The rocket continued, now a ballistic projectile, arcing through space like an artillery shell. Air vanes kept it stable. Gravity pulled it down. At maximum range, accuracy was poor, deviation of 4 to 11 miles from the target. But when your target is a city, precision doesn't matter. Arrival. The first thing you heard was the explosion. A deafening blast. A shockwave. buildings collapsing, debris filling the air. Then came the sound of the rocket, a roaring scream, arriving seconds too late to warn anyone. The ground trembled half a mile away. There was no defense, no warning, no escape. From September 1944 to March 1945, over 3,000 V-2 rockets were launched. London, Antwerp, Liège. An estimated 9,000 civilians and military personnel lost their lives. Another 12,000, forced laborers and concentration camp prisoners, perished building them. The legacy. When the war ended, the V-2 became the most sought-after prize in history. American, British, and Soviet forces raced to capture manufacturing facilities, blueprints, engineers, and the rockets themselves. Wernher von Braun and over 100 core V-2 personnel surrendered to the Americans. They were relocated to the United States under Operation Paperclip and continued their work at Redstone Arsenal. The Soviets seized the production facilities and relocated them to the Soviet Union. Both superpowers understood this wasn't just a weapon, it was the future. The V-2 introduced innovations in rocket propulsion, guidance systems, and supersonic aerodynamics that shaped aerospace engineering for decades. Sergei Korolev, the Soviet rocket engineer, used German designs as the foundation for the program that eventually launched Sputnik, the first artificial satellite, into space. On the American side, Wernher von Braun became a leading figure in NASA's space program. Without him, the Apollo moon landing in 1969 might never have happened. Was it a wonder weapon? The Nazi leadership hoped the V-2 would turn the tide of the war. It didn't. At over $1 million per missile in today's money, 20 times the cost of the V-1, it was simply too expensive. Launched only in the autumn of 1944, it arrived too late to change anything strategically. If it had been deployed 2 years earlier, before the Allies landed in France, it might have disrupted invasion preparations by targeting British ports. But by late 1944, the war was already lost. The V-2 was a technological marvel, but it wasn't a miracle. Closing. The weapon that opened the heavens. The V-2 rocket killed thousands. It terrorized cities. It demonstrated the horrifying potential of science weaponized without restraint. But it also did something else. It proved that humanity could leave Earth, that we could build machines fast enough, powerful enough, complex enough to break free of gravity and touch the edge of space. The same technology that rained destruction on London eventually carried humans to the moon. The same engineers who built weapons of war became architects of exploration. History is rarely clean. Progress is rarely pure. The V-2 is a reminder that the tools we create are shaped not by their design, but by the hands that wield them. It stands as both a monument to human ingenuity and a warning about what happens when that ingenuity serves only destruction. From the ashes of war, we reached for the stars. And in that reach, perhaps, we found something worth building toward. Not vengeance, but understanding.